Welcome to homework.
This question wants us to examine how much distance is allowed for sodium chloride. So we know that when two atoms are together, they do not carry as much potential energy, electric potential energy, but then when they are further apart, they carry more potential energy. And then when the potential energy is large enough, those atoms would prefer to just stay isolated compared to when they are bonded. So if we want to find the critical value, what is threshold energy? The threshold energy happens when the energy of atoms separated, sodium atom and chloride atom. So separated atoms, the same energy is bounded. Bounded atom have sodium, but not as an atom, but as the ion. So sodium plus. Know that ions have G than atoms. That's why they like to be in nature. Chloride ion plus potential energy separating. This when they're about to separate, the threshold value, the critical value is when we take an equal sign. And then usually these two values, if this value is they stay as separate items. If this value is right hand is large, they prefer to bind together. So this gives us, because these all the values and ions that we can just look up. So the only thing we do not know is this function is the potential, and it is, we can find it as a function of the radiance, because the potential energy is negative 1 over 4 pi epsilon naught E squared over R. So this is the equation for electric potential. It's dependent onto the charge of each atom, which in this case is just E, and then it's dependent onto the separation. So if we find the separation such that this maximum separation is the equation takes the equal sign, that gives us the maximum potential, and this maximum potential gives us maximum distance between the two atoms. So let's find it. Radius, if we rewrite the equation, is 1 over 4 pi epsilon naught E squared over negative UR. So 1 over 4 pi naught, this is actually a number we know. It's just 8.88 times 10 to the 9 Newton times meter square over c squared. This is just a constant 1 over epsilon naught. Sometimes we also call this K. And then E squared is 1.6 times 10 to the negative 19 coulomb squared over negative U. So what is U? U equal to energy of sodium plus energy over chloride minus energy of sodium ion minus energy of sodium chloride. So what is that? That is just the ionization energy of sodium is the ionization energy of chloride. The ionization energy of sodium is 5.1 electron-volt, but here we are removing electron from sodium, so it's not 5.1. And then the ionization of chloride is getting, so the ionization is 3.6 electron-volt. Yep. All right, now we enter everything into the calculator. We have everything in terms of, this is negative 1.5 electron volt. It might be easier in terms of joule. So anyway, if we enter the calculator using the SI units, we will get a radius of 0.96 nanometer. So that will be the maximum between the two atoms. If the separation is any larger, this molecule will break apart. So that is for part A, for sodium chloride. For part B, ask us to refer to and to find the separation of a different molecule. And that molecule is, let's see what that molecule is. It is potassium bromide. Okay, so everything's the same except that now we need to use ionization energy of two different atoms. We need to use ionization of and potassium plus and the ionization of bromide. Bromide is atom. So ionization of potassium, if we look it up, is 4.3 electrovolts. Then it's not really ionization. Important, it's not it's we call it electron. It's 3.5 electron. Okay, electron affinity of bromide is 3.5, so that gives us U equals negative 4.3 electrovolts plus positive 3.5 electrovolts is equal to negative 0.8 electrovolts. All the rest of the same, we use the same equation, except that now we have a different energy. The charge carrying is still E squared. Now we have 0.8 electrovolts. And again, let's use 1.6 times, let's use SI units to convert this into joule. And the final answer is 1.8 nanometer. This is a separation between the two elements, which is twice as large compared to the sodium chloride.